Hello and welcome to our video on LAGG and VLAN. In this video we will be discussing the FreeBSD LAGG protocol, how to edit the LAGG interface, how to edit a member interface, adding a VLAN, and then rebooting the system to fully configure your new settings. LAGG is a link aggregation and link failover of multiple network interfaces that provides fault tolerance and high-speed links. By allowing multiple network interface cards, or NICs, the system increases its bandwidth and redundancy. LAGG also allows you to combine the NICs so that they are viewed as a single link, and if one NIC goes down or is disabled, none of the connections are lost and only performance is impacted. So let's start by logging into FreeNAS. Remember, if you haven't changed your username and password, the login is admin and the password is FreeNAS. Make sure you change these. When you are on the main screen, scroll over to the left sidebar and click Network, then Link Aggregations, and then Create Link Aggregation. A new dialog box will appear. You will see two sections to choose from, LAGG protocol and physical NICs. First, let's talk about the different options in LAGG protocol. Failover is the default protocol. Failover only sends traffic through an active port. The active port is referred to as the master, and any other connected ports are designated failover, and become active in case of any failure of the master port. FEC, or Fast Ether Channel, is a static setup that does not negotiate aggregation with the peer or exchange frames to monitor the link. If the switch supports LACP, this should be used instead. LACP negotiates aggregation with the peer into one or more link aggregated groups. In this setting, incoming and outgoing traffic will be balanced across full duplex ports in LAGG to achieve the greatest possible speed. One thing to remember about LACP is that it is bidirectional, balancing outgoing traffic and allowing incoming traffic on any active port. Load balance is designed to balance the outgoing traffic across active ports and incoming traffic through other active ports. Load balance also does not negotiate aggregation with the peer and is a static setup like FEC. Round Robin has the same settings as load balance, but instead of choosing specific ports for certain traffic, it distributes the outgoing and round robin scheduler and incoming traffic through any other active ports. Round Robin violates Ethernet frame ordering and should be used with caution. None disables incoming and outgoing traffic. It is intended to do nothing, but is a way to disable any traffic without disabling the LAGG interface itself. The recommended options are generally either failover or LACP. If you want more overall bandwidth, you will want to choose LACP, which retains a very similar failover feature while doubling bandwidth. However, if you aren't trying to maximize bandwidth, failover provides redundancy without complexity. Next on the list of options is the Physical Network Interface Cards, or NICs. Choose the desired physical NIC and click OK. Then you will see your new link aggregation on the left sidebar. Next, click on View All Link Aggregations. Then click Edit Interface. A new dialog will appear. Here you can change the interface name you would rather call your LAGG. I'm going to leave mine LAGG 0 for demonstration purposes. If you are using a DHCP server, make sure you click the DHCP box. If you are not using a DHCP server, it is mandatory to input your IPv4 address and IPv4 netmask. I'm going to be using DHCP. IPv6 should only be checked if your DHCP server is capable of providing IPv6 address info. If so, the IPv6 address is optional, but the netmask is required. Next, click OK. Now click on Edit Members. Then Edit under the Action menu of your link aggregation. A new dialog will appear. This screen allows you to configure the individual physical interface that you specified. Since I don't have any changes to make, I'm going to click OK. Now we are going to configure virtual LAN, or VLANs for short. VLAN is a group of hosts with a common set of requirements that communicate as they are attached to the same broadcast domain, regardless of their physical location. So let's begin. Scroll over to the left sidebar and click Network, and then the drop-down menu VLANs, then Add VLAN. A new dialog will appear. Here you will see a few options that you will be able to choose from. Virtual interface needs to have the value of VLAN, then the integer that represents the interface. Next, choose your parent interface. Then input your VLAN tag, which should match a numeric tag set up in the switched network. Once you are done configuring your VLAN, click OK. Once you're done with that, you are done with the configuration process for LAGG and VLAN, and the next step is to reboot the system in the GUI to finish the configuration process. Once the system reboots, You will have completed the configuration process and should have operational LAGG and VLAN. That's it. Thank you for watching this video on LAGG and VLAN. For more information on LAGG and VLAN, go to doc.freenas.org.